Okay, let's take a look at using the DUR method for solving an equation. It's not my favorite method. It's a little more mathematically inclined than guess and check, but it's a little less mathematically inclined than using the properties of equality. But it helps us build a foundation in reading for using the properties of equality. Okay, so the D, U, and the R stand for do, undo, and result. Okay? So let's take a look at just how you set up with this organizer before we read it. The variable is always in the top left corner. So in this problem, which is the quantity x plus 7 divided by 9 equals 4, the variable is x. The result is always the lone number um, on one side of the equal sign or the other. So in this case, it's going to be 4. He always goes in the bottom right corner. Okay, now the best way to sort of conceptualize these are like stories. It's kind of like MapQuest and reverse MapQuest. So the way I kind of tell these is sort of once upon a time there was a number called X, and then somebody added 7 to it, and then got some result, and then they divided that result by 9, and this gave a result of 4. So if we were to work our way backwards in sort of a reverse MapQuest fashion, we would start with the 4, and then we would say the undo for divide by 9 is multiplied by 9. It's the only time I sanction using the dot just about for multiply. And then the opposite of add 7 is minus 7. And this will give us what x is equal to. Okay? So now then I just execute those steps and say, well, 4 times 9 is 36. And 36 minus 7 is 29. Making the answer to this problem, x equals 29. I like the word answer, so let's replace that with the word solution. This is the solution to the problem because if 29 is then plugged in for x and simplified, you will in fact get a result of 4. Okay, let's take a look at this problem, which is negative 3 times the quantity g minus 6 equals negative 12. Again, the variable is always in the top left of the do chart, and the result is always in the bottom right. One thing we could say right away, too, is that the top middle is always an equal sign. Okay? So, now let's try and get us into story mode. Once upon a time, there was a variable called g, and somebody subtracted 6 from that variable, and then took that result and multiplied it by negative 3. So, then we see to go backwards from negative 12, we will see that backwards the undo of timesing by negative 3 is dividing by negative 3. And the opposite of subtracting 6 is adding 6. So now that we've got a backwards map to some extent, we execute it and say negative 12 divided by negative 3 is 4. And then we have that 4 plus 6 equals 10. Making the answer to this equation, the solution to the equation, we say g equals 10. And again, we know that that is in fact the solution, because when 10 is plugged in for the variable in the original equation and then simplified, we will in fact get negative 12. So, getting the box set up right to start is a big help, and then from there you need to make a forward map, and then a backwards map, and then execute that backwards map to get a final result, which is the solution to the equation.